Quantum entanglement is one of the most fascinating and mind-bending concepts in modern physics. It has puzzled scientists and captured the imagination of people all around the world. But what exactly is quantum entanglement, and why did Einstein famously call it spooky action at a distance? Today, we're going to dive deep into the strange and counterintuitive world of quantum physics to explore this phenomenon. Get ready for a journey that will challenge everything you thought you knew about how the universe works. Imagine two particles that are created together in such a way that their properties become linked, no matter how far apart they are. If you measure one particle, you instantly know something about the other, even if it's on the other side of the galaxy. This is what we call quantum entanglement. But how is that even possible? How can information seem to travel faster than light, and what does that mean for our understanding of the fundamental laws of nature? Quantum entanglement challenges some of the most basic assumptions we have about reality. In the classical world, we're used to the idea that objects have properties that exist independently of whether we're observing them. But in the quantum world, things get weird. The properties of entangled particles are not determined until they are measured, and the measurement of one particle appears to instantly affect the other. This phenomenon is so strange that it led Einstein to question whether quantum mechanics could be a complete theory. He referred to entanglement as spooky action at a distance, suggesting that something was missing from our understanding. But quantum entanglement isn't just a theoretical curiosity. It has real-world implications and potential applications that could revolutionize technology. One of the most exciting areas of research is quantum computing. Quantum computers take advantage of entanglement to perform calculations that would be impossible for classical computers. Instead of using bits that are either 0 or 1, quantum computers use qubits, which can be both 0 and 1 at the same time, thanks to a property called superposition. When qubits are entangled, they can perform complex calculations exponentially faster than any classical computer. Imagine being able to solve problems in seconds that would take a classical computer thousands of years. This is the promise of quantum computing, and entanglement is at the heart of it. Quantum computers have the potential to revolutionize fields like cryptography, medicine, and even artificial intelligence. Imagine a computer that can simulate complex molecules to help develop new drugs, or one that can break encryption codes that are currently unbreakable. The possibilities are endless, and quantum entanglement is what makes it all possible. Another potential application of quantum entanglement is in secure communication. Quantum key distribution, or QKD, uses the principles of entanglement to create encryption keys that are theoretically unbreakable. If someone tries to intercept the key, the entanglement is broken, and both parties know that the security has been compromised. This could lead to a new era of secure communication, where data is protected from eavesdropping in a way that is fundamentally different from anything we have today. Imagine a world where your personal information is truly secure, where hackers have no way of intercepting your data because any attempt to do so would be immediately detected. But how do we know that quantum entanglement is real? Over the years, scientists have conducted numerous experiments to test the predictions of quantum mechanics. One of the most famous experiments is called the Bell test. This experiment was designed to determine whether the correlations observed between entangled particles could be explained by hidden variables, some kind of underlying mechanism that we simply didn't understand. The results of these experiments have consistently shown that the predictions of quantum mechanics are correct, and that entangled particles exhibit correlations that cannot be explained by any classical theory. The Bell test experiments have been repeated many times, with increasingly sophisticated techniques, and each time the results have confirmed the strange predictions of quantum mechanics. This means that the universe doesn't work in the way our everyday experiences lead us to believe. The idea that two particles can be linked in such a way that the measurement of one instantly affects the other, regardless of the distance between them, is something that defies our common sense. And yet, it's a fundamental part of how the universe operates. So, what does all of this mean for our understanding of reality? At its core, quantum entanglement suggests that the universe is far more interconnected than we ever imagined. It challenges the idea that the world is made up of separate, independent objects, and instead points to a deeper level of unity. Some physicists even suggest that entanglement could be the key to understanding the nature of space and time itself. If particles can be connected across vast distances, what does that say about the fabric of the universe? Could it be that space and time are not as fundamental as we think, but are instead emergent properties of a deeper, more interconnected reality? The implications of quantum entanglement are profound, not just for science, but for how we think about the world. It forces us to reconsider our notions of cause and effect, locality, and the very nature of reality. It also opens up exciting possibilities for new technologies that could change the way we live. But perhaps most importantly, it reminds us that the universe is full of mysteries that we are only beginning to understand. The more we learn about quantum entanglement, the more we realize how much there is still to discover. And if you're enjoying this exploration into the strange and mysterious world of quantum physics, why not subscribe to the channel? That way, you won't miss any of the videos where we dive into the fascinating questions that science has yet to answer. Hit the subscribe button and turn on the bell so you're the first to know when we post a new video. Your support helps us continue to explore the wonders of the universe and share them with you. Now, let's get back to the mysteries of quantum entanglement. One of the questions that scientists are still trying to answer is how entanglement fits into the larger framework of physics. Quantum mechanics is incredibly successful at describing the behavior of particles at the smallest scales, but it doesn't easily fit with our understanding of gravity and general relativity, which describes the universe at the largest scales. Some physicists believe that solving the mystery of entanglement could be the key to unifying these two theories into a single framework, a theory of everything. There are also intriguing connections between quantum entanglement and black holes. Some researchers have proposed that the very structure of spacetime could be woven together by entanglement. In fact, there's a hypothesis called the ER=EPR conjecture, which suggests that entangled particles might be connected by microscopic wormholes, or Einstein-Rosen bridges. If this idea is correct, it could mean that entanglement and gravity are deeply connected in ways that we're only beginning to understand. Imagine if every entangled particle pair was actually connected by a tiny wormhole. This would mean that the universe is even stranger than we thought, with connections that span not just space, but perhaps even time itself. The idea that entanglement and wormholes are related is still speculative, but it's an exciting possibility that could lead to a deeper understanding of the nature of reality. If entanglement is somehow responsible for the fabric of spacetime, it could mean that everything in the universe is connected at a fundamental level. This interconnectedness could be the key to understanding not only quantum mechanics but also the nature of gravity, black holes, and even the origin of the universe itself. But even without delving into the deepest theoretical implications, the practical uses of entanglement are already changing the world. Quantum sensors, for example, use entanglement to achieve levels of precision that are impossible with classical technology. These sensors could be used in a wide range of applications, from medical imaging to detecting gravitational waves. The potential of quantum technology is vast, and we're only scratching the surface of what might be possible. Imagine a future where doctors can use quantum sensors to detect diseases at their earliest stages, or where scientists can use these sensors to explore the most distant reaches of space with unprecedented accuracy. One of the most exciting aspects of quantum entanglement is that it challenges our intuition. In our everyday lives, we're used to thinking of objects as separate and independent. But in the quantum world, everything is connected in ways that are difficult to comprehend. This interconnectedness is not just a curiosity, it's a fundamental aspect of how the universe works. It suggests that the boundaries we perceive between objects may be more of an illusion than a reality. The idea that everything in the universe is connected at a deep level is both humbling and awe-inspiring. It forces us to rethink our place in the cosmos and consider the possibility that we are part of something much larger and more interconnected than we ever imagined. As we continue to explore the mysteries of quantum entanglement, we're reminded of how little we truly know about the universe. Every new discovery brings new questions, and the more we learn, the more we realize how much there is still to uncover. The world of quantum physics is a place where the rules of classical physics break down, where particles can be in multiple places at once, and where information can be shared instantaneously across vast distances. It's a world that challenges our understanding and invites us to think in new and creative ways. It's a world that reminds us that the universe is far more mysterious and wondrous than we could ever have imagined. Quantum entanglement is not just a phenomenon that affects particles, it also challenges us to rethink how we approach technology and communication. Imagine a world where we can harness the power of entanglement to create instantaneous communication across vast distances. This could revolutionize how we interact, enabling us to transmit information faster than ever before. The applications for space exploration are especially exciting if we could communicate with spacecraft in real time, without the delay caused by the vast distances between planets. It would open up new possibilities for exploring the cosmos. Scientists and engineers are already working on developing the technology that could make this kind of communication a reality. Moreover, quantum entanglement may also help us gain a deeper understanding of the fundamental building blocks of the universe. Some researchers believe that entanglement could be connected to the mysterious force of dark energy, which is thought to be responsible for the accelerating expansion of the universe. If we can understand how entangled particles interact with each other across vast distances, it could provide clues about how dark energy influences the universe on a cosmic scale. This connection between the very small, quantum particles, and the very large, the structure of the universe, is one of the most intriguing aspects of modern physics, and it shows us that everything is interconnected in ways we are only beginning to understand. Another fascinating area of research is quantum teleportation. While it might sound like science fiction, scientists have already succeeded in teleporting quantum information over long distances using entangled particles. Quantum teleportation involves transferring the state of one particle to another, effectively allowing information to be transmitted without physically moving it. This breakthrough has huge implications for the future of data transfer and secure communication. Imagine a world where data can be transmitted instantaneously without the need for cables or satellites. Quantum entanglement could make this possible. And it's not just about technology. Quantum entanglement also has implications for our philosophical understanding of reality. The idea that two particles can be linked in such a way that they share information instantaneously, regardless of the distance between them, suggests that the universe may be fundamentally interconnected. This challenges our classical understanding of separateness and individuality and suggests that everything in the universe is part of a larger, unified whole. This concept has resonated with many people, not just scientists but also philosophers and thinkers who are interested in understanding the nature of existence. It invites us to think about our place in the universe in a new way, recognizing that we are all connected at the most fundamental level. One aspect that really challenges our understanding is how quantum entanglement could influence time itself. Imagine that entangled particles could somehow be used to send information back in time. While this is purely speculative at this stage, it opens up incredible possibilities and questions about the nature of causality. Could we change events in the past? Or could entanglement allow us to understand time as something fluid rather than fixed? Some physicists are beginning to explore these questions, and while we are far from any concrete answers, the mere fact that such ideas are being considered shows just how groundbreaking the concept of quantum entanglement is. There's also the potential connection between entanglement and the concept of quantum consciousness. Some researchers have speculated that the interconnectedness observed in quantum systems could extend to biological systems, perhaps even the human brain. This idea, though controversial, raises intriguing questions about the nature of consciousness and whether it might have a quantum component. Could our thoughts and experiences be influenced by entangled particles? Could consciousness itself be a manifestation of quantum processes happening in the brain? While these questions are still very much on the fringes of science, they highlight the profound impact that quantum entanglement could have on our understanding of what it means to be conscious. The philosophical implications of quantum entanglement extend far beyond science. The idea that everything in the universe is fundamentally interconnected challenges the classical, reductionist view of nature. Instead of viewing the universe as a collection of separate, isolated entities, e.